Okay, so the next functional group is, or the next family is called aldehydes and ketones. So aldehydes and ketones are similar, and then they have what we call a carbonyl functional group, which is a C with a double bonded oxygen. And the position of the double bond oxygen is what makes the difference between an aldehyde and a ketone. So an aldehyde, the carbonyl group, is found at the end of the carbon chain. So however many carbons there are, then it's at the end, and it can be either end. Okay, so the end of the carbon chain. And then with a ketone, the carbonyl group is found somewhere in the interior. So again, doesn't matter how long the carbon chain is, it's found in the interior. So there is no ketones that are meth, and there's no ketones that are eth, because those don't have an interior, right? So if you have one carbon, then of course the double bond O is going to be at the end. And if you have two carbons, of course the double bond O will be at an end. There is no middle, for example. So the naming is actually super easy. Aldehydes, the ending is Al. Ketones, the ending is ONE. So methanol is one carbon, and ethanol is two carbons. And again, whichever way you want to draw that, it doesn't matter. And then ketones, so you have to start at least one higher than it has to be at least prop, and you have to say where, put the number of where the ketone is. So like 3 hexanone. So draw your hex is 6, draw your 6. And then whichever one you prefer. So if you like to go from this way, like 1, 2, 3, then that will have a double bond oxygen, and the rest of them just have hydrogens. Okay, so pretty straightforward. Now, technically with the aldehydes, you could put a 1, but because it has to be at the end, like it has to be carbon number 1, then sometimes that's not written like that. Okay, so let's see. I mean, there's not really much. You could have, like a ketone, you could have 2, try to sneak one in here, 2-butanone. Up here, you could have hexanol. And again, it doesn't really matter where you put the double bond O. Okay, so aldehydes and ketones are lacking in hydroxide groups, therefore their boiling points are lower than alcohols with the similar molar mass. So they cannot, so because they do not have OH, so no OH, then they can't hydrogen bond with themselves. So they can only accept hydrogen bonds from water. So when they're small, so again, usually we say less than or equal to 4 carbons. So that property is similar to like an ether, okay? So then as molar mass increases, so does the boiling point. So when you have aldehydes and ketones undergo a special reaction called oxidation. So oxidation in organic chemistry is a reaction when carbon atom forms more bonds to oxygen or less bonds to hydrogen. So once you make a bond to oxygen, then obviously carbon would have to give away a hydrogen. You can't have more than 4 bonds, right? So in this course, you need something to oxidize the organic molecule, and these reactions can be pretty tricky. So we're going to use the symbol O in square brackets, or depending on the textbook, grade 12 textbook you Google, it might be like a O in regular brackets. That doesn't matter. To simplify or symbolize the oxidizing agent. So really, an oxidizing agent is usually potassium permanganate or potassium dichromate. Your textbook uses, the question in the textbook, I believe, is sodium dichromate. Okay, so all of those, when you see those this year, you can just write O in square brackets. Okay, so there are 2 basic types. You're going to either oxidize an alcohol to make an aldehyde, or oxidize an alcohol to make a ketone. So in general, you need some kind of alcohol and the oxidizing agent, and you're going to get an aldehyde or a ketone. Oops. And then, of course, look what else. Oh, water. Okay, so I'm going to show you in general how this works, but then you don't need to worry about, we're going to leave them unbalanced, sorry. So that is like a second year organic chemistry thing, should you choose to continue on with pure chemistry. Okay, so in order to get an aldehyde, then remember the aldehydes are at the end. So if you want an aldehyde to be at the end of the chain, then your OH also needs to be at the end of the chain. So we need a primary alcohol, like we'll use ethanol. So a primary alcohol was one where the carbon attached to the alcohol had 2 free hydrogens. So wherever the oxygen is, then now, so that's, let me see if I can get this to highlight. So like right here, now that is going to change into a double bond. That's what oxidation is, okay? More bonds to oxygen. So now it's got 2 bonds to oxygen. And so then you have to get rid of, so now it's got 3 bonds, so it's only going to need 1 hydrogen. So there's this hydrogen here, and the hydrogen from the hydroxyl or alcohol group that would come off, and then the other product is water. So again, the oxygen that goes into water comes from the oxidizing agent, but really we're not going to stress about that, okay? So that is ethanol. And then when you have, when you want to make a ketone, then you're going to do what we called a secondary alcohol. And this was an alcohol that we'll do the simplest one, 2-propanol, okay? The OH was on a carbon that had only 1 free hydrogen. I'll make that orange. Instead of 2. But if you know that aldehydes have to be at the end of the chain, then it makes sense. If that's where the alcohol is, that's where the double bond's going to go, which makes an aldehyde. And then if you have a molecule with 3 carbons, then that is going to make a ketone. I'll do the same thing here. So again, you're making 2 bonds to oxygen, which means now that carbon is full. So we've got, actually, if you want those to be the same, you've got the hydrogen coming off, one of them coming from the OH group, and then the other one coming from the oxidizing agent. So this would be, let me see if I can, there we go, 2-propanone. And then the third kind of alcohol we did, which was tertiary, where the carbon had something like this, no free H's. Therefore, this does not react. No oxidation reaction. You can't make any more bonds to oxygen because this carbon here already has 4. Or it would have too many, you'd have 5. So if we were in class, we would actually do a lab with this where you would have tested a primary alcohol, the secondary alcohol, and you would have gotten an oxidation reaction, and then the tertiary alcohol you wouldn't have. So it's actually pretty easy to prove. Okay, so give the questions a try. They're not super difficult. And if you have any questions, please let me know.